Greetings, welcome to MATHguide.com. This video is going to instruct you how to tackle the activity called volume of an open box, the dynamic variety. Stay tuned. So you now have to determine the volume of an open box. So the first thing you're going to do is click on this link, and this link will send you to this interactive quiz on MATHguide.com, and what it's going to do is tell you the length and width of your particular rectangular cardboard sheet. So everyone's going to have a different length and width. So imagine you were given this cardboard and this cardboard was in a rectangular shape with this certain length and width. Now going back to your activity, you're going to write down that length and width right here. Okay, then what you're going to do is imagine cutting out little squares at the corner of each end here of this rectangle. And what would happen is then those little squares would be discarded, and you have now 4 little openings in your cardboard sheet. You're then going to fold this cardboard sheet along those lines, and what's going to happen is you're going to get this shape once you fold it up. Okay, so you fold them up, you'll get that open shape. Now with that open shape, you're going to have a challenge. Your challenge is going to be to determine what is the length and width. Well, see, it depends on what x is. If you let x stand for just a general amount, just a general value x, you could use some algebra to determine what this length is. Okay, so it is crucial that you understand that you're given this length, which goes from corner to corner. But now if you cut off those rectangles, you are now going to have a shorter length. So you're going to have to do a little bit of algebra to determine how you would write an expression for that length. Likewise, since you're cutting out these squares, your rectangular sheet, once you fold it up, is no longer going to have the full length. It's going to have these 2 pieces missing. So you, again, you have to figure out what's the expression for the width and fold it up. So that's probably the hardest part of this assignment, is getting these expressions, because once you get these expressions, you should know how to calculate the volume of a prism. The volume of a prism is length times width times height. Okay, so once you get that expression for the volume, which was number 2, you'll get the expression for the volume. You're then going to graph that. So you're going to throw that expression into a graphing calculator, and it's going to give you a shape. Okay, so you should see some shape on your calculator, and you might have to adjust the window size to be able to see that shape. When you put that into your calculator, it gives you a window size of, I think it's like from 10 to -10 on your x, and then from -6 to 6 on your y. It's just too small. So you'll have to adjust the window size to see the whole thing. But once you get the curve and you get it drawn, you can make a sketch of it. And just keep in mind that for determining the domain, which are the acceptable x values, just think about how small x can be and then how large x could be. And you have to really think about this rectangular sheet you were given to determine what those x values can be. Okay, then lastly, you're going to use the volume and your graph to determine the maximum volume. Okay, so in other words, you're going to figure out within the domain, within your acceptable x values, what would be the largest volume. Okay, so you'll use your calculator to do these, to find this maximum volume. And then what you're going to do is write that down here. So write down your maximum volume, and then write down the size of the squares that have to be chopped off of your rectangular sheet. Good luck.